Good morning, friends. I have another short but interesting video for you. This is interesting in the sense that I'm not discussing any particular substantive theory or any concept. Actually, I will not give you details of different concepts that I'm using in this. I want to keep it short. But the central message of this presentation is that research is never perfect. Uh, in research, you make various kinds of errors. You must be aware of what kind of errors you are going to make, which errors are possible. And all the errors cannot be minimized simultaneously. So you have to choose which errors you are more willing to make so that other types of errors can be minimized. That is the central idea. So I'm sharing my slides for this purpose. And here are the slides. Uh, and the title of the presentation is Quality of Research Depends on Your Choice of Errors, not on your efforts to make your research perfect. There are no perfect results. Uh, some of you may be shocked to read this, but on the basis of my experience and my reading and my researches, I am saying that there are no perfect results. In what sense? In terms of scientific evidence, which would not misguide anyone, nor the scientific community, uh, nor the consumers of research, uh, or anyone, or policymakers, which would not suggest options costlier than the target groups can afford. Or if you do the cost benefit analysis of use of the knowledge uh, against non-use of the knowledge, in a large number of cases, you find that not using knowledge is more beneficial from several points of view, including money point of view, than using the knowledge. So, or research would not have any adverse impact on target groups in short or long run. It is it is impossible to avoid side effects uh, in the short run or in the long run of any kind of discovery in medical fields or agricultural fields or energy field or sociology or psychology or political science. And your everyday experience shows that our civilization is built on knowledge which science gives us, or science applied to social sciences, politics, etc., etc., gives us. And subsequently, we suffer from the consequences of application of that knowledge. Friends, let me start with a simple thing like conducting a survey. Most sociologists, social scientists conduct surveys. Economists also conduct surveys. Political scientists conduct surveys. Psychologists conduct surveys. Uh, Now, in these surveys, one of the consideration is sample size. What should be your sample size? Sample size is determined on the basis of how much error you can tolerate, in what percent of cases, and what are the uh, tentative estimates, or what are the estimates of your variables derived from your pilot study or previous studies done in the similar context. There are two types of errors in all sample surveys that you make, type 1 and type 2 errors. Normally, for fixing your sample size, you can go for Cochrane formula or other formulae used more in management researches for limited population. You find that the sample size is determined on the basis of type 1 error only, and you do not consider type 2 error, which is a serious issue. Actually, you should fix both type 1 and type 2 errors and determine your sample size accordingly, but that does not happen. Similarly, researchers have shown that order and wordings of questions also matters. You must become aware on the basis of literature. You must become aware of consequences of using different formats, organization, and order and wording of questions, and then decide which is not done uh, in most cases. Then asking sensitive questions. In research, I myself use such questions because I work in the area of health, HIV, stigmatized communities, uh, and etc. etc. So, uh, and several UNICEF surveys and many global surveys have asked these kinds of questions. We have also asked these types of questions in schools and colleges and in village setup. Uh, the example of such questions is that we ask a respondent, do you have an extramarital relationship? Now, who will say, which woman would say that she has an extramarital relationship in the village? No one. So, uh, but you find that these types of questions are commonly asked and results are discussed. Maybe they serve the interests of the donors, but they are they correct? I very much doubt the validity of these kinds of findings based on personally sensitive questions. Now, somebody can say that there are technical ways of handling these situations, and randomized response technique is one. I have used randomized response technique. The problem with this technique is that there is no clear understanding of probabilities of choosing various options. So, maybe a separate video would be required on uh, randomized response technique or all the concept that I'm discussing in this presentation. Just confined to this idea that there are many possibilities of errors, various types of errors, and you cannot minimize all the types of errors together. Similarly, in drawing inferences, there is a tendency among scholars to show uh, that something is significant at 0.05 level with 1 star, zero point zero 0.01 with 2 stars, 0.001 with 3 stars, meaning thereby that something which is significant at 0.001 is also inference wise more significant. I differ. Because when you are trying to minimize your type 1 error, when you are reducing type 1 error alpha, then you are raising the type 2 error. Both the errors cannot be minimized simultaneously. Not only mathematical statistics will show this, even a simple diagram I am going to show to you will show that both the errors cannot be minimized simultaneously. Then what is more important for you? Is probability of rejecting the null hypothesis when it is true is more important, or probability of uh, accepting it when actually some other hypothesis is true, means your null hypothesis is false? What is more important for you? You decide, you take a decision. In purely mathematical statistical terms, uh, we decide these things on the basis of the power of the test, or 1 minus probability of committing type 2 error or beta. This would be the probability of rejection of null hypothesis when actually uh, alternative hypothesis is not true kind. So this is power. Power. Uh, uh, we want to increase the power of the test, or 1 minus beta. Uh, so you decide what is important for you. Non-rejection of hypothesis may also mean you are incurring large type 2 error and accepting the false hypothesis. There are several hypotheses which may or may not be rejected at your level of alpha. You fix alpha, suppose a correlation coefficient, you want to test a correlation coefficient, and the value of correlation coefficient is zero point 0.1, and you say it is not significant. Have you tried that if the correlation is zero point 0.2, then also it is not significant. A point 0.3 can also be not significant because significance depends on your sample design. It also depends on your sample size. So be careful whenever you are making a bold statement. Actually, uh, maturity in research is reflected in your becoming more adaptable, flexible, modest, rather than taking hard stands. Because knowledge is not perfect. Now, uh, this figure shows that you either in statistical inference, you either reject null hypothesis or you do not reject null hypothesis. As a matter of fact, we do not even use the term accept something. We say either you reject null hypothesis or you do not reject. Do not reject does not mean you accept it. And there is a technical reason for this. We do not accept null hypothesis ever. We only say that whether we are rejecting it or not rejecting. And imagine that there are four kinds of situations. Null hypothesis is true and you are rejecting it. It's a type of error, and the probability of committing this error is called alpha, type 1 error. Uh, if you do not reject null hypothesis and null hypothesis is true, then you are taking a correct decision. Similarly, when null hypothesis is false and you are rejecting null hypothesis, then it's okay. But if null hypothesis is false, alternative hypothesis is correct, and you are not rejecting the null hypothesis, then also you are committing an error. So, friend, you have to be careful about, and this figure especially shows something interesting that you fix your um, statistic at some level on the basis of 0.05 or zero 0.1 or 0.001, that if my uh, sample value of t or z or f or chi-square is more than this, then I will reject the null hypothesis. If less than this, then I will not reject the null hypothesis. But you see, if you are trying to minimize or you're trying to reduce the type 1 error, means you are on this graph, you are moving towards the right hand side. What is happening? The type 1 error is reducing, but the blue portion, type 2 error, is constantly increasing. So here is a problem that alternative hypothesis um, uh, is true, but you are actually not rejecting the null hypothesis. And you can see that both the errors cannot be minimized simultaneously. Okay, so also in selecting measurements, where do you emphasize? Those who are dealing with policy issues, biomedical statistics, clinical trials, they should be more worried about these things. One aspect of uh, your measurements is sensitivity, that your measure should be such that all those patients or all those people with a certain characteristic should get identified. If this is true, then your measures are sensitive. So sensitivity is one property. Sensitivity means that all those with a certain characteristics be identified. But there is another thing. There can be false negative, false positive. Another thing is specificity. Means that those without that characteristic should not be identified. So it may happen to blood tests, it may happen to MRI, it may happen to other types of images, it may happen to X-ray or any kind of test, and uh, you can see that sensitivity and specificity, both the things cannot be increased simultaneously. If you want a more sensitive test, it will become less specific. If you and let me demonstrate this with an example from socioeconomic studies. For example, in a study of poverty, which is very common in social scientific domain and also in policy research, you find that there are so many estimates of poverty. Poverty in India. What is poverty in India? Government of India will give you one estimate. Some NGOs will give another estimate. Global bodies will give some still another estimate. So why? One of the reasons is this is problem of sensitivity and specificity. If you keep the poverty line higher, then you are estimating a, uh, you are overestimating the head count ratio. Suppose you say that in India we consider those people poor uh, who have a per capita income of 20,000 rupees or less, then almost the whole India becomes poor. If you say that no, 20,000 is too much, I will say that for poverty line, it is okay if I fix it at rupees say 1,000 per capita per month. But then you are likely to underestimate the poverty rate or the head count ratio or poverty ratio, poverty population ratio. Which error you want to make? You must make uh, clear to yourself at least that you want an overestimate or underestimate or some kind of optimization for certain policy purposes or the purposes for which research is being conducted. Also, you have all heard about type 1 and type 2 errors, and maybe some of you have also heard about power 1 minus beta, 1 minus probability of committing type 2 error. And type 2 error means you are not rejecting the null hypothesis when actually it is false. Alternative hypothesis too. But there is another error, and that error, um, in some books, it is referred to type 3 error. What is type 3 error? Type 3 error means that the hypothesis itself was framed wrongly. You have not done sufficient review of literature. You have not discussed your problem with experts and specialists. You have not attended seminars, workshops, conferences on your theme. And you have just randomly, because you find them interesting, so you have randomly selected some hypotheses to test. If these hypotheses themselves are wrong, then in your statistical inferences, you will have type 3 error. Similarly, if a concept is wrongly operationalized, if a concept is wrongly operationalized, results cannot be true. Also, have you bothered about non-sampling errors? Non-sampling errors is a very large category of errors, uh, which includes non-response. If non-response is related with selectivity of respondents, then certainly your results are in error. Telescoping and errors of measurement, etc. Error of data entry and uh, errors of wrong choice of inferential statistic or descriptive statistic. Everything comes under non-sampling error. You have to be very well. I have seen that some surveys. I was recently talking to someone who studies voting behavior, and he was claiming that in most cases his results were okay. And the reason was that rather than uh, thinking too much about sample design, whether it should be random or probability proportional to size or multi-stage or what, they pay more attention to reducing non-sampling errors. Establish rapport with the respondents and try to collect the correct answers. Yeah? Try to read the mind of your respondents correctly and be careful in data collection, data entry, analysis, what statistics should be used, and so on. So, a non-sampling error should also be considered carefully. Uh, yes, some people think that results of design of experiment or scientific design are more scientific than the survey research, and they rely more on ANOVA. This happens more with experimental psychologists and with medical scientists and also with agriculture. But these days, experiments are also being used in economics. A new field of economics has come up, which is called behavioral economics or experimental economics. Now, friends, when I read literature on analysis of variance, I face certain problems. Suppose you are comparing five groups at a time, and your F ratio may be significant or insignificant. The problem is in and your null hypothesis is that means of all the groups are same. Now there are two possibilities. You come up with an overall conclusion on the basis of F, or you compare uh, two groups pairwise. When per comparison type 1 error rate in five groups is 0.05, alpha is 0.05, and you are comparing two groups, maybe with the help of t-test, uh, maybe with the usual formula of t in with denominator like s1 square by n1 plus s2 square by n2, or with a more adequate definition uh, as 2 of mean sum of square, 2 divided by 2 ms divided by n kind of. Then uh, yes, I am saying that when type 1 error per comparison is fixed at 0.05, family-wise error, which happens in the interpretation of F ratio, its probability is 0.14, which means in 14% cases, at least one of your conclusions about pairwise comparisons is wrong. 14% is very large. Suppose you have eight groups and you fix alpha at 0.05, then roughly your um, error, family-wise error, will become 40%. 40% error. What kind of results you have in which there is 40% error in family-wise error? So be careful. If the family-wise error rate is to have a smaller value, then per comparison type 1 error rate must be much smaller. Okay. Then I say I'm not fixing it at 0.05, I'll be fixing it at 0.01, so that uh, uh, it becomes only it becomes only 5% for family wise. But then you are increasing your type 2 error, beta. You are increasing, you are compromising with the power of the test. You are increasing beta, type 2 error. There are so many, some people think, some researchers think, the papers which come to me for review, I have seen that in recently there is a tendency to do post hoc analysis and use some of these tests given on the right hand side of this slide. All post hoc estimation methods given here are basically to minimize family-wise type 1 error rate for a given per comparison type 1 error rate. But first of all, it's not clear which method is more correct. It depends on various assumptions. It depends on your situation. And you must clearly understand all the assumptions um, made behind all different methods of post hoc estimation. And then has your sample size been fixed for both alpha and beta? That is, that you ask to yourself. Sometimes we also make error in choosing qualitative methodology or quantitative methodology or a triangulation. I will not go into details here because I have separate videos on quantitative methods and qualitative methods. You can see my videos there. Uh, but if you are using qualitative methodology, you make an error. When do you make an error? You make an error if you are using qualitative variables in a positivistic framework. Positivistic framework means studying an objective reality in dispassionate manner, value neutral manner. The assumption, the ontological assumption of reality being real outside our consciousness. And then it's not subjective, it's real. You are not worried about effects of your biographical situation context, beliefs, and values on the findings. Or when you are reading others' research work, you are not concerned about effects of their biographical situation, context, beliefs, and values on the findings. So there is a problem. And you need to revisit your ontology. Is it possible to have findings which are really independent of researchers and context? Similarly, if you are using quantitative methods, there are problems. Quantitative methods cannot be used indiscriminately in all types of cases. If the purpose is to study experiences, like experiences, we have used in some researches in which I was a consultant, we have used structured interview schedules to study people's experiences uh, of, say, opening of coal mines, closure of coal mines, experiences of environment, experiences of employment, experiences of income, experiences of allied activities on agricultural productivity and things, and so on. Political mobilization, voting behavior, inequality, and so on. But for experiences, quantitative methods are not the right methods. Um, if you want to have an in-depth understanding of behavior, means if you have to interpret behavior in the light of the context in which behavior occurs, then you should go for qualitative methods, and you are committing an error. No matter how exact you are in terms of your alphas and betas and surveys and tone back alpha and this and that, reliability and validity, there is a serious basic problem. People's perception cannot be captured in quantitative methodology uh, or through quantitative methods. Similarly, there is a problem in studying collective decision making. Quantitative methodology is not good for collective decision making. What it means is that when you talk to individuals, they express one kind of view on something, or they express one kind of attitude. But when they meet in a group and talk about that issue, they arrive at a different position. Then the community's attitude is different. And uh, simple sociological rule that community exercises a kind of constant on people's minds, subjective mind or individual's mind. And collective decision making or moral decision making is often different from individualized or private decision making. So that is a serious issue. And quantitative methods are not good for collective decision making or for studying something in totality. Case studies are better for that, not quantitative method. In case studies, you have a higher degree of freedom and you can include more number of variables in the study. Uh, okay. Similarly, when you analyze your data, simple, nobody bothers. Simple things like to capture descriptive situation, you can calculate mean or mode or medium or harmonic mean or geometric mean. Very few of you have ever uh, taken the headache to go into merits and demerits of these estimates. You have very few, even those students who know about the differences between mean, mode, median, harmonic mean, and geometric mean, do not know in which situation use of harmonic mean or geometric mean is better than using mean, or in what situations mode is better. There are four tests of goodness of different measures, uh, uh, inferential measures particularly, and also descriptive measures, uh, that they should be unbiased, they should be efficient, they should be sufficient, and they should be consistent. Means they should be in the long run, or for large sample, we should get the correct results. The means of possible sample means should be same as the true value of the parameter. And there should be minimum sampling fluctuations. So um, all all the errors cannot be minimized simultaneously. So which error can be sacrificed? This is an independent topic, and one can talk about this issue alone for 1 hour or more. Which error can be sacrificed? So first you try to understand what is unbiasedness, what is efficiency, what is sufficiency, what is consistency, in what situation or in what estimators, what kind of errors is more, then which error can be sacrificed, and you should go for parametric methods or non-parametric methods. Even at the time, at the end of the research, at the time of publication of papers and reports, you make errors. What kind of error? If you are doing a donor-driven research and it is sent for publication to an academic journal in public domain without the approval of the donor, uh, and you do so sometime, many scholars do this because they have to build their CV, their career, their promotion, their visibility, that depends on their CV. But think of consequence. This is unethical and erroneous. This is unethical because some donor may ask you to do some research in confidence, and you are making your results public. This is unethical. And also, from practical point of view, these donors will not come to you again for research. So you lose there. So there is a cost of committing this kind of error. Also, if you are doing purely academic research and it is sent to impress policymakers without any clear direction about how they can be used for becoming, uh, how they can be useful, just for, why is researcher doing so? It's an academic research. It's about knowledge. It's not about policy making. It's not operations research. Still, the researcher is sending it to state or government uh, for becoming visible in the state circle. So that is another kind of error, because most of us commit that kind of error. So what is the result? The result is that ministries hardly bother about your research. Our researchers pile up in libraries of ministries, and minister or secretaries or section officers, none of them ever consults research, even monitoring and evaluation report. Nobody can. They just um, get collected in the ministry somewhere. Nobody touches because you have done it purely as an academic exercise. You have not come up with findings which are implementable, feasible, and of interest to policymakers or ministers or secretaries. So, friends, in conclusion, in this very short video, I just wanted to say that no research is perfect and all researches contain some or other kind of error. So, uh, in a right state of mind, in planning your research, choose your errors carefully. That yes, I acknowledge that in this research I am making this kind of error. But by making this kind of error, I am also trying to minimize all other kinds of errors which are possible in research. So this is the conclusion. So choose between the errors carefully. No research is ever free from any kind of error, friends. Uh, I stop here. I hope you find this idea of choosing between errors an interesting idea, and you will make use of it in your future research. Thank you very much.